Enter your register numbers in message box. Right. Good morning. So, space and trade-off we were discussing. In that, still two more topics are there in fourth chapter. So, one is called hashing, another one is called a Bayes-Moore algorithm. I hope. So, these two I'll tell you next. First, I'll tell you the dynamic programming. In this, you have the 3 laboratory programs are there. So we'll finish this, then we'll come back to that one. So that is what my plan. So let me do first dynamic programming. So in this, laboratory programs are there, and apart from that, maximum questions from the 4th unit in this one only they'll be giving. So that is the reason we'll learn this first, then we'll move on. We'll go to the hashing and Bayes-Moore. Only 2 topics left out in that. So here is dynamic programming. In this, you have the Warshall's algorithm, Floyd's algorithm, and one more is on this Floyd's, Warshall's. Another one is one problem, 0 bar, one knapsack problem. So all 3 are important. So all 3 are there in the laboratory programs. Let us learn one by one. And one more also, binomial coefficients also is there. 4. So in this 3 laboratory programs are there. AB is there. So let us see how it will work this. And easy one, once you know the matrix multiplication algorithm logic, you can use this one. And apart from that, dynamic programming definition first we'll discuss. So screen is visible. Screen is visible?
Yes, sir.
Yes. So now, today date is 9. Dynamic programming. So dynamic programming, what is the definition for this? Dynamic. So whatever we are talking about the C programming dynamic. So dynamic is nothing but there what we'll say static and dynamic memory will be allocated during the runtime. That is what the dynamic will say. Static is nothing but fixed memory allocation. So when you are writing the program itself, we are entering the memory allocations. That's what we used to do it. Here dynamic programming is nothing but the dynamic programming, you are also solving the problems, but the definition says is nothing but solving the overlapping problems. So that is what this technique is nothing but what? Solving the problems with overlapping subproblems. So the definition is solving the problems what problems with overlapping subproblems. This is what the definition, solving the problems with overlapping subproblems. That means what? You have the problems. So in that solving overlap. Finally, suppose if you are having n factorial is there, 1 into 2 into 3 into 4 into 5 into 6 into dash dash n minus 1. In this, what we'll be doing, first 1 factorial we are writing, next 2 factorial we are writing, next 3 factorial. So once you have the 3 factorial, so next 4 factorial is nothing but 3 into 4 only. So 3 factorial answer is there already. next you are doing. So like this, you will be going the solving the overlapping the subproblems. That is what the dynamic programming. So always solving the overlapping problems. So finally, you need one answer for that previous one, previous one, previous one. You are coming to the zero level. So there you are doing. So that means what will happen? Like insertions are what we have taken. We have taken one small instance, and using that we have solved the remaining problem. So one part we have taken. Here also, what will happen? Part by part, part by part. Overlapping is nothing but n minus 1 is nothing but what I told you, n minus 2, n minus 3, n minus 4 dash 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 up to 4 3 2 1. So one, you know, once you know this, 1 factorial is nothing but 1, next is 2 factorial, next 3 factorial, next 4 factorial. So like this we are going one by one. That is more the solving the overlapping problems. Now I am having one question. So student, you can ask me one question. So like recursion also like overlapping only there also. There also overlapping problems only. So what is the difference between that one and this one? So factorial n is nothing but what we have done. So factorial n is nothing but, so if n is equal to 0, return 1, else yeah, fact of n into fact of n minus 1 you have done it. So there also the same procedure only will be doing. So there some difference is there, and here some difference is there. So there you are using stack you are doing, but here is we are using the memory allocations, like storing the values you are doing. Like ordinary arrays you are taking, that values you are storing here. But in a recursion, what you have done is we are not bothering where it is storing. So that is temporary memory allocations, it will be storing, and finally you are getting the result. So what will happen there? Fact of 5 means 5 into fact of 4. Next is fact 4 values, 3 into fact of 4, 4 into fact of 3. Next is 3 into fact of 2. Next 2 into fact of 1. Like this it will be storing, and system will be calculating. We are not bothering where we are storing, but in this we are storing that values also. That is what the difference between recursion and here. That's what the question that sometimes they will be asking, what is the difference between divide and conquer and dynamic programming. So here is, this technique was invented by American mathematician Richard Bellman in 1950. So Richard Bellman, he has invented this in 1950. Richard Bellman. Richard Bellman. No, yeah, only Bellman. So this is what the here when 1950. So 1950 has invented Richard Bellman dynamic programming. Now let us see what will happen. So dynamic problem properties is nothing but an instance is solved using the solutions for the smaller instances. That is one. And second one is nothing but the solution for the smaller instances might be needed multiple times. So store their results in the table. That's what I told you. Here the answers you are storing into the table. So that is the reason you are taking the array. But recursion, we are not storing. The system will be storing in the temporary memory allocations. Next is the each smaller instance is solved only once. So here is any smaller problems will be solving only once. So additional space is used to save the values. So here is additional space is required. All the values we are storing, and we are given problems we are making into the smaller instances, smaller problems, dividing into the smaller problems. That is what the dynamic programming. Now sometimes they will be asking, what is the difference between divide and conquer and dynamic programming? Divide and conquer. Another one is the dynamic programming. Whenever they are asking any differences, put the table and write it. The first one is Here is partitions of the problems into the independent smaller subproblems. Partition problems are independent. Partition problems are independent. So independent small problems. That's what this already we have learned it. Now in this dynamic program is nothing but what? Partition a problems into the overlapping subproblems. So partitions are making into the overlapping subproblems. So here is partition problems are divided into overlapping subproblems. That is what this one. Now there with respect to the memory allocations, so here is does it will not store the resultant the overlapping values. So sub solutions we are not storing. So that is what the here is don't store the values of the sub problems. So sub problems values are not storing here. Subproblems values are not storing here, but in this case stores all the subproblem values. Store all the subproblem values. Now here is top-down algorithms. Here is bottom-up algorithms. Bottom-up algorithms. So here is divide and conquer is nothing but what? Already you have learned it. Partition problems are independent smaller problems. For example, if you take merge sort, what will happen? Merge sort, what happened? So any problems you are making into the two parts, again first part and second part. So one next what you will be doing, first partition again you are making into the two parts, again first partition. So like this you will be getting small instances, you are dividing, then you are adding that one. So all that values we are not storing anywhere. We are not storing anywhere because you are using the stack concept. So stack concept, using the stack concept, it will be solving the problems there. So that is what the recursion there. But in this case, all sub problems we are storing into the system. So here space also required in the dynamic problem. All overlapping sub problems we are storing the values. That is what the difference between there and here, because they are asking 4 to 5 marks, you write it there. So here is first difference is nothing but what? The sub problems, it will be dividing into the independent smaller sub problems here, independent smaller sub problems. But here is nothing but what? Partitions are divided into the overlapping sub problems. Now here is, it will not store the values, but in dynamic programming, it will store all the values. And here is top-down approaches will be solving top-down here. So here is bottom-up approaches will be solving. So finally, you need one result. For that, you will be solving one overlapping problems. So that is what the difference between divide and conquer and dynamic programming. So that's what they'll be asking to 3 marks or for 2 marks. So we should know this. Next one is nothing but, so let us go for the example problems. Dynamic programming, divide and conquer already we have discussed, and we'll go directly for the dynamic programming problems. Now here is, we have some of the rules of the dynamic programming. So anybody staying nearby college? Anybody staying nearby college? Third semester students. So if anyone comes, I'll give you the notes. You can take that notes and you can send it to somebody so that it will be easy for you to learn it. Anybody staying nearby? Okay, so let's see that one. Right. So now rules for the dynamic programming. Rules for dynamic. Rules for the dynamic programming. Now, first one is the optimal substructure. First one is what? Optimal. Second one is called the overlapping subproblems. And third one is called the bottom-up fashion. So now we'll see what is the optimal substructure. Is nothing but an optimal solution to a problem contains optimal solutions to the subproblems. Optimal subproblems is substructure is nothing but what? Any problem you are having. So for that it will be overlapping some of the previous problems. That is what the optimal substructures you will be solving. Next is overlapping subproblems is nothing but a recursion solutions contain the small number of distinct subproblems repeated many times. So here is overlapping subproblems. What will happen is nothing but a recursive solutions contain the small number of the distinction subproblems will be having. So recursions is different and overlapping subproblems is different. So overlapping is nothing but so any problems you are that one in that one more problem in that one more problem, that is called the overlapping subproblems. Recursion is nothing but way of solving is like second unit already we have seen. That is what the recursion problems. Now bottom up approach is nothing but what you need some of the last values for that destination you need it. For that what you will be doing previous problem, previous problem, previous problem, previous problem. So you will come to the starting point. So one more problems will be solving and going. Finally, you will be getting the answer. That is what bottom up approach. So their top down approaches is nothing but so you know the top down approaches what we have done in the dividing and conquer. Now from top to bottom we are going. So finally we will be getting the answer. So here is bottom up approaches. So from last to first one will be coming and will be solving and going. So now once we solve this any problems, now we'll come to know how it will be working. So when I'm saying this, so you'll be having bit confusions here. So once if I solve one or two problems, then we'll get to know what is called the overlapping problems. Now divide and conquer, you I hope you are not having any doubt. So there we have done quicksort also, we have done mudsort, we have done how we have done is nothing but we made the partitions. Then again that partitions we are split into the smaller problems. That means what? First partition again we are making the two partitions. Again we'll come to the first partition. So again we are making the two problems. So that means what? Till you get small problems, we are going recursively there. So once you get the small problems, then we'll be solving is easy. Then we are going back. So for that system will be taken. So we have written only for one repetition there. So only one iteration we have written, remaining it will be taken care automatically recursion. Now here is how to write the overlapping problems, we'll see it. So sometimes in examination rules for dynamic programming also 2 to 3 marks they are asking. So sometimes this everything we know we will not remember this. So before going for examination you see it and go this also. So now the basic components of the dynamic programming solutions is nothing but the recurrence relation, tabular computation, a backtracking procedure. So these three things we need to follow and we have to solve the given problems. Now examples, problems in the dynamic programming is nothing but already I told you. One is called the binomial coefficients. Right. Examples. Right. So examples is nothing but examples. So one is called the binomial coefficient. Second one, you have the compute the longest of common sequence. Anyway, it is not there in our syllabus, so no need to write that one. Another one is called the Warshall's algorithm. Next one is called the Floyd's algorithm. And the last one is called the Knapsack problem. Binomial coefficient, Warshall's algorithm. Another one is called the Floyd's algorithm. Next one is called the Knapsack problem. So all four are there in your laboratory set. So in this one is, I hope, two problems. One is A and B is there. So like totally three problems are there. Let us see that how it will be working. They have done with binomial coefficients one more. Floyd and Warshall's algorithm is one, and Knapsack problem is one. So let us see that one how it will be working. So the first one is called the binomial coefficients. Binomial coefficients. So binomial coefficient, what is the formula? Normally, binomial coefficient formula, a recursion formula. So just for understanding purpose, I am telling a recursion formula. What is the recursion formula? Anybody can say this recursion formula? Anybody know this? For example, if you are having a NCR formula, just what is the NCR formula? Tell you, huh? Kavya? What is the formula? Diksha?
Yes, sir.
What is the formula for NCR? You learned discrete mathematics also, binomial coefficients also you learned it. What is the formula? Hmm? You have done many programs, also C programming. Spurti?
Sir, n factorial by n minus r factorial into n factorial.
n factorial divided by n minus r factorial into
that's what n factorial by n minus r factorial into n r factorial.
Yes, very good. So you have learned it this n factorial divided by n minus r factorial into r factorial. So NCR, so n factorial, you know how to calculate there. So when you want to write the C programming here, what you will do? Enter the coefficients of the n comma r. So for example, 4C2 if you want. So first one you will be sending n factorial 4 factorial value, you will be calling this function. One function factorial you are writing. Next n minus r you are subtracting here, you are calling the values the same function, and r factorial also directly, for example 4C2. So that is equal to 4 factorial divided by 4 minus 2 2 factorial into r factorial is 2. So like this you will be calculating and you will be getting the answers. So there what will happen, this is what the recursion what you are doing. Now what we have to do it here, so how to solve the overlapping problems. So this, you know this, for example if you want to write this function is nothing but what you will be doing. So read n r. So how to write the function is nothing but, so fact of n divided by fact of n minus r into fact of r. So this is what you will be writing. For this you will be writing the function int fact int of n. So if n equal to 0, return 1, else n into fact of n minus 1, that should be written. So this is what the recursion problems you will be writing. So what will happen for all three independent values, you are written the same function. So fact of n also you will be using the same function. Fact of n minus r also same thing. This also same thing. So this is what the problems you are having. The recursion is nothing but what? It's the independent problems. It's the independent problems. So now we have to see how it will be working the overlapping problems. This is what the syllabus you will be starting. Now you will see the second one now. Put the heading binomial coefficient using dynamic programming. Binomial problem first. So write it. Binomial problem. Right. Now, simple algorithm. Just when you are writing the algorithms, you have to write this table. Then nothing difficulties. Only thing is how to write the algorithms. So now just first I'll tell you the algorithm, then we'll go for the problems. Now you have the I and j values. So you have the table something like this. So one is represents I values, another one represents the j values. So I values will be incrementing like this, j values will be decrementing like this. So j goes from 0, 1, 2, dash 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 k minus 1 comma k. N minus 1. Here is we are taking 0, 1, 2, 3 k minus 1 comma k. So now j values we are taking 0, 1, 2 dash dash up to n minus 1 comma n. Just listen, you can copy it here. Now you need to compute the values. So here is NCR we are taking previous one, but actually we are taking here NCK. So that's what the textbook they have given. So with respect to NCR is nothing but NCK we are doing. So now we need to compute the C of N comma K. So what is this values is nothing but nth row and K. This is what you need to compute the values. Listen 1 second, then you can copy. Compute the N comma K. So now you want to compute this for this. How you will be getting this is nothing but you have to add the previous one and this one. Now what is the previous values in this case? C of N minus 1 left hand side. Listen all of you, then you can copy it, comma K values. And this previous values is nothing but what? C of N minus 1 comma K minus 1. C of N minus 1 comma K minus 1. Another one is nothing but the K of N minus 1 comma K. So if you want, I'll rewrite once again this space problem. C of N minus 1 comma K minus 1. Okay, so is it okay for you? Understood? I'll tell you once again, binomial coefficients algorithm, how to write it. If you write this table, your algorithm over. Arjun, is there? Where is Arjun? Ashok?
Yes, sir.
Ashok? So, understood this, how to write?
Yes,
You
sir.
have the values 0, 1, 2, 3, 4, K up to K, J values. I values is 0, 1, 2, 3 up to N values, N minus 1. Now you need to compute this value C of N comma K. C of N comma K is nothing but nth row and K. That's it. You are seeing the table and you are writing. Your job is to remember 0, 1, 2, 3 dash dash up to K. This one is nothing but 0, 1, 2, 3 up to N. That's it. So now this value how you are getting is nothing but previous value. Previous location is nothing but what? Compute of this row is nothing but N minus 1. Column is same. And one more previous values you have to write it. These two adding, you will be getting this. C of N minus 1 and previous same row. Row is nothing but we are not doing anything. And K values is nothing but previous one. So this is nothing but the K minus 1 is nothing but this values. And this is nothing but this and this. So this is what the way of writing the tables. Remaining is whenever you have the 0 location 0 comma 0, so that it will become 1. So j values whenever you become zeros, that value is always 1. So now 0 comma 1 also we need to calculate 1 comma 1 also 1. So like this you will be calculating here 1 will be there here. So one more value I'll write it here 1. So this values if you want 1 plus 1 2 and here's this is nothing but the 1. So like this you will be writing the values. So once you know this how to write the table, algorithm is simple. Now tell me the algorithm how to write. I'll tell you algorithm. This is nothing but binomial. You need to compute with n comma k. Write it n comma k. Algorithm binomial n comma k. Right. So here is compute C of n comma k using dynamic programming. Using dynamic programming. Using dynamic programming. So you want to calculate the C of n comma this one. So integer values is nothing but input is nothing but you need to give the always. For example, 4C1, 4C2, 4C3, 4C4 I can calculate it. 4C5 can be calculated binomial. Spurti. 4C5 can be calculated. Arjun?
No, sir.
No, we cannot calculate it. So that is what the input restrictions is there. So input integers always. So n is greater than or equal to k, that is greater than or equal to 0. So up to this condition is satisfying, we can do it. So n is greater than or equal to k. Up to there only we can give it. That means 4C4 I can calculate it. 1C1, 2C2, 3C3, 4C4, 5C5, up to there only. 5C6 we cannot calculate it. So that is what the input restriction. Now write it for I goes from, so you know this, I goes from where to where? 0 to 0 to, in the table you see it. I values is up to where to where? Up to where to where? Arjun. Ashok.
0 to n.
0 to n. That's it. 0 to n do. Next, for j is equal to up to where to where?
0 to k.
0 to k. So I told you n is greater than or equal to k. So in this, what you have to do is 0 to minimum of, which is the minimum, you have to take it with respect to I comma k. This is what you have to write it, because so what will happen is I goes from, for example, if you take 1, so k loop is nothing but 0 to k. So for example, if you give for 5, so what will happen? 1C1, 1C2, 1C3, 1C4, 1C5, 1C6. So up to 6 we cannot calculate it. We have to stop with the 0 only. That is the reason, which is the minimum. Either I is the minimum or k is the minimum. You stop it here only. You need to write this condition is extra. We have to remember only this. That's it. If, write it, j is equal to 0 or j is equal to I. So j is equal to j location 0 or I is equal to j. That means what? 0 comma 0 value will be 1 and 2 comma 2 is nothing but 1 and 4C4 also 1, 5C5 also. That means I values and j values wherever you are getting equal. That is also you are storing 1 and j values, the first column always you will be getting 1 only. So that is what you have to write it. A of I comma j is equal to 1. So are you getting this step how to write it? So shall I make it here round? So this values, that means what? This values. How to write that values is nothing but, that is what this statement. A of I j is equal to 0 means this one. J is equal to 0 means what you have run? 1. So that's what I have assigned it. And now if you come to this, so in this case, j also 2, I also 2. That's what I is equal to j. That is also become 1. Are you getting what I'm saying? Arjun? Arjun? Spurti?
Yes,
Yes.
sir.
Are you getting how I wrote the previous statements?
Yes, sir.
Right. Now you tell me another one is else a of I comma j is equal to here previous table. C of n comma k is there. Can you able to see? Spurti?
Yes, sir.
So place it C of I comma yes, we have written compute n comma k. No, they just put the heading a of I comma j. So now the previous how you are getting C of n comma k, the previous values you are adding C of n minus 1 comma k minus 1 plus C of n minus 1 comma k. So wherever you have n, put the values for the I. Wherever you have j values, k values, put the k and tell me the statement how to write it. This statement, Spurti. Once again, I'll tell you. See, listen here. C of n comma k, how you are getting is nothing but you are adding the previous two values. Correct now? Spurti.
Yes, sir.
So now n minus 1 is nothing but what I have written is n is nothing but I. K is nothing but
J.
J. So now you these two adding and tell me change it wherever you have n, you tell me I, wherever you have K, tell me the J. That's what you have to say now. This is two statements, add it and tell me. A of Spurti.
Yes, sir. 1 second.
C of n minus 1 is there, K minus 1 is there, plus C of n minus 1 comma K. So replace n with I, K with J. That's it.
Sir, A of I minus 1,
A of I minus 1, very good. Comma,
J minus 1,
very good. Next one. Plus,
plus A of I minus 1, J.
that's all. Any problem to write this program now? Spurti?
No, sir.
So by seeing the table, can you write the program now?
Yes, sir.
Yes, this is one part of the program, 1A. So if you do write it this and your main program, you know how to write it. I'll tell you that also when we are discussing the laboratory session. So like this only you have to learn the programming. I don't know how you people have learned it the previous one, and also I told the same way only. So this is what the way of learning. So no need to by heart it. So here is compute n comma k is there. So write it the previous values. Now initialize how wherever you got it one values. That's what you have written it here. So now I values have written it here, J values have written it here, and you can see the table and you can write the values. That's it. So that is what the writing the values. Now I'll tell you the simple calculation. So 4C4 I want to calculate it. Example, 4C4. I want to calculate it. Write the values 0, 1, 2, 3, 4. Now 0, 1, 2, 3, 4. Right. Have you copied the algorithm?
Yes, sir.
Right. Sunil? Ashoka? Ashok?
Yes, sir.
Yeah. Copied, no, all of you? What about others? Spurti copied?
Yes, sir. Copied.
Diksha? Chaitra? So they are not responding only. See, Chaitra? Copied?
Yes, sir.
You have to
Yes,
copy
sir.
madam
Copy.
once, then only you will understand. If you are not copying, you will not understand. That's what I can say. Right, textbook you will not get this much in detail there. Right. So now who will respond now? Ashok. Ashok. Ashok.
Yes, sir.
So now you have, can you able to see 4C4 table?
Yes, sir.
Yeah. So now what we have written, where you can assign the values, either j is equal to 0 or j is equal to 1. Now j is equal to 0 means this one. So this is nothing but the j values, this is nothing but the I values. Now j is equal to 0 means first column all values, what you got it? What we have to write it?
0, 1, 1, sir. 1, 1.
1, 1. Shall I write it 1, 1? Anybody is having doubt this? Anybody is having doubt?
No, sir.
Right. Now 0, 0, 0 C1, C we can write it. Can I write it now 0 C1? No, not possible, because I values is greater than or equal to J only. That conditions only you have to write it. Now you can we go for the second row? Second row first element we have written. Second row second element. So here is what you have written algorithm is I is equal to J. So that means 1 is equal to 1. Ashok. 1 is equal to 1. Tell fast, time up. Ashok. Spurti.
Yes, sir.
So 1 is equal to 1.
Yes, sir.
Yes. Now what I have to write it in correspondingly 1 comma 1.
Sir, I didn't get you.
Madam, here algorithm is visible, no? What we have written, J is equal to 0 or J is equal to I. That's what this statement, no?
Yes, sir.
So if both are satisfying, A of I comma J is equal to 1. Now 1 comma 1 to be calculated here. When we are calculating 1 comma 1, I is equal to J. So condition is both condition is true means A of I comma J, what values you have assigned in the algorithm? A of I comma J?
1, sir.
1. Now what I have to write it is called 1. Now
One.
A of 2 comma 1 already we have entered 1. Now A of 2 comma 1 we have to write it. A of 2 comma 1 already whatever you formula you have told we don't want. Now what we have written here, previous statement to n comma k, previous value corresponding and previous values corresponding. So that means what? So here is 2 comma 1. 2 comma 1 is nothing but the above value correspondingly. What is the value you are having?
1, sir.
1. So for that left hand side, what value you are having?
1.
1. 1 plus 1?
It's 2, sir.
2. That's it. You have to write it that one only. Are you getting what I'm saying? So what values A of I comma J you told is A of I minus 1 comma J minus 1. That is called the previous value. That is nothing but this value. And what you told one more plus A of I minus 1 comma J. That is nothing but this value. These two should be added. Right. Now A of 2 comma 2. 2 comma 2 is nothing but, tell fast. 2 comma 2. I
Sir,
comma J equal.
it's 2 only.
Madam,
And
I
answer,
told,
sir, answer is 3.
Madam, 2 comma 2. I is equal to J means first condition, if condition.
1, sir, 1.
1. I comma J means I value, J value is both are equal. Then you have to write it 1 only. Now come to the A of 3 comma 2. So 3 comma 2 is nothing but whatever you have told the previous values plus left hand side of the value. Now tell me this. A of 3 comma 1.
Sir, 3.
Yes. Next 3 comma 2.
2, sir.
Madam, above 1 correspondingly 3 comma 2 how much?
Above. Sir, I didn't get you. 1 second.
A of 3 comma 2 we have to calculate it.
Yes, sir.
3 comma 2 if you want to calculate it, so I is not equal to J, so in that case else part whatever you have told you write it. So corresponding above value and left hand side value previous values you have to add it.
Yes, sir.
Above 1 is there, previous one is 2 is there. Now how much your answer? 3 comma 2.
4, sir.
How you got to 4?
So above value is 1 and the next value is 3. So 3 plus 1 could be.
Above row only. Above row, above 1 is 1 for that left hand side.
Okay.
That's what I have written here arrow mark also, no?
Yes, sir. Yes.
Similarly, you take it for this also now. 2, how you got it? You know, no, what you told? 2, the 3, how you got it now? You have 3, comma 1.
The same way, sir. Like
Tell me.
the above one.
Locations you tell me. Locations you tell me. 3, comma 1. You have told 3. How you got which locations you have added? A of
Um, A of I mean,
no. You tell me directly. A of 2, comma 1. A of 2, comma 0. Correct? No.
yes, sir.
Now similarly you tell me for A of 3, comma 2 also.
So
Above
it's
1.
2. Above one. I mean, above 1 and next to the value it's 2.
So how much now?
Answer is 2.
Which location?
A of 3 comma 2.
A of 3, comma 2. Above location is which location?
2 comma 2, sir.
2, comma 2. How much is there?
1.
1 is there. For that left hand side is how much?
2, sir.
2. 2 plus 1 is how much?
It's 3.
You are telling something else.
No, sir. I told 4. I mean, I got confused.
Now 3, comma 3 you tell me.
It's 1.
1. Now tell me 4, comma 1.
4. I mean, it's 4 only, sir.
4, comma 1 is 4. Right. Very good. Next 4, comma 2.
Next 4 comma 2. Sir, 1 second, sir. 3. Sir, it's 4.
4, comma 2.
2 comma 4. 1 second, sir. 4.
Madam, just above value for that left hand side value. Add it
Sir,
both.
it's 6.
Why you are getting confusion?
Sir, I'm
Next,
seeing the next value. That's why I'm getting confused.
next 4, comma 3.
Sir, it's 4.
4, comma 1. 4, comma 4.
1.
That's it. Do you have any problems to write now?
No, sir.
And anybody is having doubt, please let me know this. Because you are one end, I am on one end. If it is we are using Blackboard, okay, I can tell you there. Now anybody is having doubt how to write it. Even you can ask Spurti, we can tell afterwards also, I hope. What Spurti? Okay. You can tell to others also, no?
Yes, sir.
Yes. So now because I cannot interact with all 50 people, so I can interact with 1 or 2 only. So that people only should tell to others also if they are having doubt. Arjun, Ashok, Sunil, any doubt? Any doubt? Okay. Now your homework is six C6. Another one is 6C2. Both the tables you have to write it. 6C6 and 6C2. 6C6 and 6C2. Okay. This I will send it to your mail IDs. Today's class. You can see it if you have doubt later. So last class I have sent it. No, is it okay like that? Right. By the time I will take the attendance, I will send it today. This one. Answer attendance. When you have other test, 6th, 7th. Answer your attendance 1, 2, 3,
Present, sir.
4,
Yes, sir.
5,
Present, sir.
6,
Yes, sir.
7, 8, 9, 10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15, 16,
Present, sir.
17, Deepika, 18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22, 23,
Present, sir.
24, 25,
Yes, sir.
26,
Yes, sir.
27,
Yes, sir.
28,
Present, sir.
29,
Yes, sir.
30,
Present, sir.
31,
Present, sir.
TD
TD
series.
series 2, sir.
Right, madam. 3,
Present, sir.
4,
Present, sir.
5, 5,
Present, sir.
6,
Present, sir. 6 present, sir.
5, Pawan Kumar, 7,
Present, sir.
8,
Sir, 5 present,
Present,
sir.
sir.
Hello.
right, sir.
Sir, 5 present.
Right. Next to 8,
Present.
Rakesh,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Yes, sir.
12, 13,
Present, sir.
14,
Yes, sir.
16, Shruti, 17, Sneha,
Yes, sir. Yes, sir.
18,
Present, sir.
19, Srinidhi, 20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
anybody else?
23 present, sir.
All right, madam. How was the test? How was the test? Spurti?
Sir, it was fine.
Written all the questions?
Yes, sir, we wrote.
Okay. So still I have not started the evaluation. No? I will do it tomorrow because first I have started with